Hello, good afternoon or good morning, depending on where you're logged in from. My name is Mike Kramer. I am the Calibration Inspection Program Manager at Perry Johnson Laboratory Accreditation, and it's my pleasure to present to you all this month's monthly webinar, which is going to be on centers around PJLA's policy on measurement traceability, which is PL number 2. As always, this webinar is being recorded. Feel free to go to our website, go to the webinar tab, go to the recorded webinar tab if you'd like to re-listen to this webinar, or perhaps you have a colleague that may have missed it. Also, there's a wealth of information there from past webinars. If there's a particular topic of interest, feel free to listen to them at our which are available to you on our website. Also, the individual slides are available. So perhaps you just want the slides, do your own training. Feel free to acquire the slides from our, through our link on our webinar. Questions. Today's topic, of course, is PL-2. Please keep questions related to today's topic. Should have a box provided to you. So if you have a question concerning this area that we're talking about today, feel free to type them in. At the conclusion of the webinar, and that's the first time I can actually see them, is when we conclude the webinar. We'll go back and review them, and I shall answer them the best to my ability. Those that are presented to me. So PL-2, that's today's topic. Those of you all that are accredited with PJLA or perhaps in the application stages, we recently sent out an update notification. Updated, you can see PL 1, 2, 3, 4. So be sure that you have the latest and the greatest, which is available again on our website, www.pjlabs.com. So as I mentioned, PL-2, not a whole lot of changes here. So in comparison to the previous version, one thing with all of our policies, we updated all references, of course, to remove any references to the 2005 standard and updated them to the applicable changes of ISO IEC 17025 2017. Some verbiage there, removed reference to calibration labs and stated provider, since this area touches on more than just calibration labs. And we also added, if we have any folks that are under our 17034, which is reference materials, we added a section addressing traceability for reference material. Okay, metrological traceability as defined in the vocabulary of international metrology is a property of a measurement results where the results can be related to a reference through a documented, unbroken chain of calibrations, each contributing to the measurement uncertainty. You see, I highlighted that word uncertainty, which is you can see it's in the definition there from the vocabulary of international metrology, and how that's going to be needed with each link building upon the link that was provided before them. So during accreditation assessments, of course, we're looking at traceability. We're looking at a lot of things that go into that. Now, we wouldn't be accrediting a calibration organization if they weren't providing traceable measurements. So we're looking for that unbroken chain of comparison, assuring that the measurement uncertainty is documented and is built upon the uncertainty that was presented by the chain before your link in the train of traceability. Going to ensure that documentation is in order folks that are doing the calibration, stating that the measurements are traceable, their competence, and it's being referenced to the SI units. And that calibrations, it's not a one-time thing, that there's a calibration intervals associated with the calibrations that are being provided to the customers as far as the calibration of their standards and their reference materials. All these are subject to the accreditation assessment. One thing I want to bring it to light here at the beginning is the concept of in-house calibration, which is something that we address in PL-3. Or excuse me, that'll be next month, PL-3. PL-2, measurement traceability. And we define it as a calibration performed by an organization of its own equipment for use in its accredited calibration or testing activities. By definition, an in-house calibration is a calibration the organization is not accredited to perform. An organization must establish traceability for the results of in-house calibration with the same degree of rigor required of accredited calibration. So, in other words, if you are calibrating your own standards, let's say, for example, you have a pH meter and you have buffer solutions that are traceable, and you going to do those calibrations in-house instead of sending them out. If you have balances and you decide for whatever reason, hey, we're going to calibrate our own balances. What an in-house calibration basically is stating here, it's going to be the same as an accredited type calibration, except there's something that's not published on your scope. So as far as things like measurement, traceability, competence, uncertainties, all those things will come into play for in-house calibrations. One thing I want to highlight here is that if you are performing any in-house calibrations and you are accredited with us, we need to know about that before we come out and do the assessment. Reason being is 17025, we're looking at the technical competencies of the organization. So the assessor is going to have a background in the testing field you're in. So if you happen to be performing an in-house calibration, someone's competent in that area is going to need to evaluate it. So we always hear about the unbroken chain of comparison, the link to traceability. There's a simplified example of an applicant organization perhaps going to traceability to a higher level organization. By saying that, I mean another perhaps accredited organization that has smaller CMCs. They have higher resolution on the equipment than what you're submitting. Of course, the comparison of your equipment should be made against a standard of higher accuracy or resolution, and the CMC or the measurement uncertainty associated with that should be small enough to meet your needs. So that's what we're referring to, a higher level calibration organization that may in fact go directly to a national metrology institute, such as in the US, NIST. And we'll reference the SI and how traceability is to the FSI through the National Metrology Institute. So estimation of measurement uncertainty must be calculated for each part of the chain, so the overall uncertainty of the measurement can be calculated. So for example, when you send your standards in for calibration, that report should have an uncertainty associated with that particular calibration. You can look at that as your starting point. So you have an uncertainty associated with that, hence you're going to have contributors that you're going to build onto that. So a chain of traceability exists when all the measurements are known or can be known for each link or comparison along the associated uncertainty of measurements. Each link has an associated uncertainty. The further you get away from the SI or the origin, for example, in this picture, it would be better if it was depicted with the links getting a little bit larger each time you get away from, in this example, NIST. As I said, by definition, your measurements are not traceable without that stated uncertainty, and your uncertainty is going to be built upon those links that came before you. So a broken link may be an instance, for example, that a measurement uncertainty was not estimated for that calibration, and thus traceability would stop at that point. So this comes out of, we stress this in PL-2, but right out of the standards 651. 6.5 is a section on metrological traceability. The laboratory shall establish and maintain metrological traceability of its measurements by a means of a documented unbroken chain of calibrations, each contributing, again, to the measurement uncertainty, linking them to the appropriate reference. We keep hearing that term SI units, and right out of the standard, the laboratory shall ensure that measurements are traceable to the International System of Units, SI, through calibration provided by a competent lab, or if it's a reference material, certified values of certified reference materials provided by a competent producers with stated metrological traceability to the SI, or see there, and this comes right out of 17025, direct realization of the SI units ensured by comparison directly or indirectly with national or international standard. So the SI, they're base units. They are the standard units of measurements defined by the International System of Units for the 7 base quantities of what is known as the International System of Quantities. They are notably a set from which all other SI units can be derived. So what are they? SI base units, currently we have length, mass, time, electrical current, thermodynamic temperature, luminous intensity, and amount of substance. You can see the base unit there: meter, kilogram, second, ampere, Kelvin, Candelaria, and mole. One thing of a particular interest here is that these values, the speed of light, the behavior of atoms, freezing point of water, the nature of electromagnetism, are fundamental features of nature that don't change. Whether the observer is on Earth or in Mars, whether it's the year 1875 or actually it should be 2022 there. They're based on national phenomena. One thing I wanted to bring to light here is the kilogram, which has always been a fascinating area for me. I used to love telling the story when someone, back when I was involved in state weights and measures, was there was one perfect weight in the world, and it was actually a man-made artifact called a kilogram that was kept in the International Bureau of Standards in France, where everything was, all your mass weighing was linked to this physical artifact. However, recently, and it was been on the drawing board for quite some time, that national prototype, the 1 kg man-made artifact, was actually, they had statistics showing that it was losing mass over time. And they've recently developed an exquisite accurate weighing machine known as a Watt's balance, which measures an object of mass by calculating the force needed to lift it. And you can see it's called a Planck's constant. It's quite detailed. It's been in the drawing book for some times, but in a nutshell, the physical man-made kilogram has been replaced by this Planck's constant. So no longer have to worry about the mass artifact losing weight over time. You see a tiny uncertainty associated with that Planck's constant, which is 13 parts per billion. So again, with SI, we keep hearing that term. So when you are receiving an traceable calibration, you should, or if you're providing them, make sure that you're providing evidence that measurements are traceable to the SI. and you should reference that. If the organization chooses to reference this traceability on calibration certificates, it must reference it to the SI when possible. So we do address this in PL-2. Used to see it quite often, not as much as used to doing assessment. A lot of folks like to say in the U.S., we're traceable to NIST, where our measurements are traceable to the National Institute of Standards and Technology. The folks at NIST caught on to that. Do not like to see that. It's not correct. And basically, you are actually traceable through the NIST or the NMI, if you're coming to me from another country, through your National Metrology Institute to the SI units. And we have an example in PL-2 of how that can be worded. Calibration results published in this certificates were obtained using equipment capable of producing results that are traceable through NIST to the International System of Units. So once again, it's not appropriate when you're referencing traceability, or if you do see it on a certificate that you got for perhaps your equipment that you sent in, and if it's saying traceable to NIST, that is not correct. Okay, PL-2, we go into sources of traceability, appropriate and approved traceable sources for having your standards calibrated, your equipment. At the top of the echelon that chain there would be going directly to an NMI who is covered by the CIPM MRA, and basically they are listed in the International Bureau of Weights and Measures Key Comparison Database. So in the US, we're talking about NIST, NIST. You can go directly to the source, and those higher level calibration labs, often the higher level ones, will have a standard sent directly to the NMI, hence allowing them to have a smaller starting block to build on. Upon, when I say that, I mean their uncertainty or their CMC. If they go directly to NIST, NMIA, or the applicable NMI, then they're going to build upon that uncertainty that was provided to them by the NMI. So the CIPM MRA is the framework through which National Metrology Institutes demonstrates the international equivalent of their measurement standards and the calibration and measurement certificates they issue. So NIST, of course, is a member of that, or a recognized entity. Also, you can, as far as traceability sources, you can go directly to an accredited provider for the calibration, just to be assured that it's covered under the scope of accreditation. And they are accredited through an entity that is recognized under the ILAC arrangements, regional arrangements recognized by ILAC, which we are an MRA signature here at Perry Johnson. There are a few others here in the U.S. that fall under the MRA. We are actually under the Asia Pacific region, the APAC region, and they come in and assess us. And we recently just had that done, and assure that we are assessing to their policies, their procedures, and also the requirements specified in the standard that we comply with, 17011. So they assess us and anybody else who is part of the mutual recognition agreement. That symbol on the certificate, I always like to say, it's a big stamp of approval. The measurements are traceable because the laboratory has been assessed in its ability to provide traceable results. It has been established. This means that an investigation actually took place during the assessment to determine the chain of traceability is unbroken. Things like the measurement uncertainty was looked at, the procedure, the personnel, the competence of the procedure, the facilities, the environmental conditions, all were evaluated. Then the organization would not be accredited if they were not providing traceable results. In PL number 2, we do reference in the U.S. In the U.S. Constitution, Article 1, Section 8, from way back in 1901. Basically, back then was National Institute of Science and Technology, which created, which then became the National Bureau of Standards, which now is NIST. Basically, in a nutshell, in this Office of Weights and Measures has recognized state laboratories that they provide certificates of traceability through its Weights and Measures program. Most states are part of this program. Not all have a state lab, state metrology lab. The scopes are not the same for all organizations. However, PL-2, we do recognize them. That program is providing traceable measurements. They have a rather intensive program they put the state metrologists through, depending on what level you are at. As far as training, they have their own system of proficiency or round robins, and we've deemed them as a traceable source. There is an example of a state that has a certificate of traceability on file at NIST, Office of Weights and Measures. The bulk of the state lab's work is in the area of mass, weights, weighing. You can see this particular state is an Echelon 2 lab. So there's different capabilities. Of course, there's a lot of difference between doing a high precision analytical type weight that's going to be used on a precision balance as opposed to doing a 1,000-pound block that's going to be used on a truck scale. So if you go through a state lab, make sure that their capabilities meet your requirements. Most state labs are practically all of them are accredited to do mass in one echelon level or the other. Go to this next one. You go get gasoline, or if you're on the deli having your lunch meat weighed, you may see these types of stickers on there. That means they were checked by state weights and measures official. So the state labs were initially started to support commercial weights and measures, buying and selling gas pumps. So if you look at a gas pump, they should have a sticker on there, similar to the one we have here from Virginia, that it's been inspected by the state, and through their weights and measures program, those standards that were used to check, say, the gas pump was traceable standards. However, the state labs are now being utilized more and more by industry to provide the link of traceability for their clients. Different states have different capabilities. Going back to this one here, you see tuning forks, for example. That's used to standards that are used to check radar guns. Some states actually have lottery balls on their certificate of traceability. If you think about it, that's got to be a totally random process. So those ping pong balls, they should be weighing pretty darn close to each other. So you can be assured if your state is weighing them and they have a certificate of traceability that on file, that they've been checked and calibrated through a traceable source. All right, so we mentioned going directly to the NMI, going to a 17025 accredited provider, and if need be, you can go to state weights and measures. It is possible, however, to provide traceability through an NMI that's not recognized and through a calibration facility that's not, say, accredited through 17025. And we do address this in PL-1. So we have a documented process in place. In PL-2, there's some extra hoops. I like to put it in that fashion. Extra hoops that would have to be presented in order for those measurements to be determined to be traceable. they're handled on a case-by-case basis. We reference in PL-2 a LF, one of our LF forms, a 123, which is available on our website. We make this relevant information available to our organizations, and if you need to utilize another source other than a source that's not accredited or recognized to an NMI, you'd have to go through this, and approval will be needed. So with the LF 123, we look at the 6 elements of traceability, and they are provide a ideally, the first thing we'll be looking at is the report that was provided to you. And on that report should be a clearly defined quantity that has been measured. For example, the actual size. If you're doing, let's say length, for example, if you're doing a micrometer or a caliber, if it's measuring in inches or millimeters, that quantity should be specified on the report. Should be a complete description of the measurement system, the working standards that was used to perform your calibration. Key thing that's going to be looked at here also is are those supported by a traceable calibration. Number 3, of course, is uncertainty. That the report would have to have a stated uncertainty that would be reviewed. Should be on the report, and as we stated at the very beginning here, through our definition of traceability through the VIM, that is a needed element in order for the measurements to be considered traceable. Provide a complete description of the stated references at time of the measurements or working standard at which compared to it. In other words, your unit under test, what you are sending off, that has to be provided on the report. Perhaps it's a caliper or a micrometer, sticking to that example. So that needs to be identified on the report, and ideally a unique identifier such as an ID number or a serial number should accompany it. The organization should provide evidence of an internal measurement assurance program. So in other words, that they're doing something else other than just having their standards calibrated. They have some sort of intermediate checks in place. Ideally, proficiency testing. And last but not least, and if you're going through us, chances are you would going to have this to keep your accreditation, is the organization seeking the service of the non-accredited source has to have a system of internal measurement assurance and program in place. So in other words, the integrity of the calibration needs to be maintained. So at PJLA, like I said, the LF-123 would need to be completed, and documents and records associated with the verification would need to be made available to PJLA staff or assessors upon request. So we reserve the right to reject the claim of traceability if the option of PJLA, in the opinion of PJLA, all the requirements and objective evidence that we just went through, 1 through 6, does not meet the requirements for establishing traceability. So I mentioned objective evidence that would be reviewed. So your organization can plan on, along with the report of the unaccredited provider, the report associated with the equipment that was used to your calibration. Ideally, hey, was it from a accredited source, 17025 recognized, or the NMI? Evidence that the organization and the equipment is evaluated between calibrations. There's something in place. It's just not calibration interval, nothing else, however long that may be. So ideally, check standards, control charts, repeatability studies, and ideally proficiency testing, like we require our organizations to comply with PL-1. That they ideally are comparing their results to other organization results. And of course, uncertainty. So you may ideally that should be on the report, and may be possibility that we may have to actually look at the uncertainty budgets to assure that all significant contributors have been considered. So if you're an organization and you go to an accredited source, a couple other things you may want to consider. Just because the organization is accredited, you want to make sure that you are getting the accredited type report. So in other words, I know some calibration labs have different levels of reporting. If you do need traceability for the measurements, you want to make sure, well, first of all, to assure that it's coming under the lab scope of accreditation, that perhaps the accreditation or the accreditation body symbol is referenced on the report, that the before and after data is included with stated uncertainty. So of course, if you'll need that uncertainty, if you need to calculate uncertainty yourselves, of course you need to know if your instrument was in tolerance or not, because if it was out of tolerance, then you may have to do some non-conforming work. Also, review the laboratory scope of accreditation. Just because an organization is accredited, you want to assure that they are accredited to perform the calibration that you need. And actually, this should be part of your evaluation under externally provided products and services, i.e. purchasing, where you are required to evaluate your suppliers and monitor their suppliers, have some sort of criteria in place for approving suppliers. So ideally, 17025 would be a good qualifier as far as approving a supplier for traceability reasons. All right, we also, PL-2, we reference traceability for testing, and basically the requirements for testing is the same. Unless it's been established that the uncertainty of the calibration is not a significant contributor to the uncertainty of the test results. So in the event that could be the possibility in some testing arenas that its traceability to the SI is not possible, the testing organization shall demonstrate traceability to certified reference material applicable and accepted reference standards, methods, or consensus standards. So again, if calibration is not a dominant factor in the testing results and the associated uncertainty, the laboratory is to have evidence to substantiate or confirm the fact that traceability of the equipment or calibration results do not be demonstrated. So in other words, during an assessment, you're going to have to show some proof, some documentation or a record to support that claim. I mentioned we do at PJLA, we do have under our umbrella 17034, which is for reference materials. And we have added a section in PL-2 in regards to reference materials, CRMs, that's certified reference materials. We're looking for traceability. Values assigned to certified reference material produced by MMIs are included in the same database through the International Bureau of Weights and Measures or by an accredited RPM under the scope of the accreditation. And in this case, that's 17034. That's for reference materials. So if you're looking for traceability for reference materials, for example, pH buffers, if you have like gas concentrates that you are using for a link of traceability, you can go through a accredited reference material producer or go to the NMI in the same manner you would for traceability under 17025. All right, that is the going to conclude our presentation on PJLA's policy on measurement traceability, PL-2. So if you bear with me a minute, I'm going to, as I mentioned before, I am going to I do got questions here. Bear with me, it's taking a minute to load things up. And I'm reading these exactly as they were typed. Calibration programs and plans of reference standards documented and implemented is not enough. If implemented, could be evidence of traceability. That's a question. So I'm not sure exactly what the question is there, but you're talking about reference standards there. So basically, if we're looking for traceability, again, going through a source of an NMI or an accredited organization, the LF 123. If not, like I said, they could be providing traceable calibrations, but they have to jump through some extra hoops. What if the in-house calibration? What if the in-house calibration pH meters are not used for any of the accredited tests? Okay, well, we're concerned with when we go doing accreditation or those things that are on your scope of accreditation. So you have different levels of accreditation. And if you're using another type of report, the main thing you want to be concerned with is that you're not misleading your customers in any way. And if you are stating on the report, whether or not it's accredited or not, that you are providing traceable results, then I would hope that you would have be able to support that claim. So whether it's accredited or not, if you're making the claim that it is traceable, you should have documented evidence to supporting it. And like I mentioned, 17025 and PL-2 goes through some various means of assuring measurement traceability. All right, this one here, I advise you to stay tuned next month. We give classes on measurement uncertainty. Could you advise on how to estimate remote? I think that's remote for temperature chamber, autoclave, ovens, cold rooms. You know, I can what I can say as far as any sort of measurement uncertainty, you always have three elements in there. You have the uncertainty associated with the standard. So if it's temperature, you have a thermometer, a standard that you're using, that comes off the report, and then you start building on that. So typically you would have, on top of that would be on any type of uncertainty budget, no matter what it is, or uncertainty contributors, uncertainty of the standard, uncertainty of the limited resolution of device under test. So in other words, if that autoclave has a display in it, that last unit, that display resolution is always a source of uncertainty. And repeatability. So you need to do a repeatability check on your standard, a standard deviation. Those things are also included. Other things that may be included would be uniformity of the cold room or autoclave that you're referring to, stability of your standard. There could be some drift associated with that. There's uncertainty associated with that. This one, a technical question. Another one, we sent our PRTs in Germany for traceability. How to consider the calibration result in our best measurement capabilities. Typically, when you, of course, I mentioned earlier, when you get that report from the NMI, in this case, the German NMI, should have the measurement uncertainty on there. Typically, when it comes off of a report from your provider, that's considered a normal distribution, which you need to look at the K factor, in other words, the confidence interval. So if you're getting off the report, and I can tell you 99.5% of the time, the K factor should be 2. So basically, if you're taking that report and you're plugging it into your contributors there, you would take that value off the report, divide it by 2, because that's the distribution time. It's a normal distribution divided by 2. Why do you divide it by 2? Because the NMI, if it says K equals 2, has multiplied it times 2 to give you a 95% confidence interval. So I would assure that the report should say that it's K equals 2, and you would take that uncertainty, you would divide it by 2, and then you put it in that spreadsheet where it does all that root sum squared magic, and that contributor would be included. Evaluation of measurement uncertainty, how to be done? Well, like it's a measurement uncertainty. We're going to be talking about that next month as far as PL-3. Probably give some examples of some uncertainty budgets there, but it's just a matter of identifying the contributors to uncertainty, quantifying, got to give them a value, and then you combine them. And then typically you would expand it. Can you please explain the NIST traceable statement? Basically, when you reference traceability, and we actually have it in PL-2, and I don't remember exactly what section that is in, but when you reference traceability, you reference it through the NMI. So you won't say traceability to NIST. If you want to, the proper way to state it is you are traceable to the SI through NIST. Again, this is in PL-2, and an example is given in there of how to word that. But basically, you want to state through NIST. Can an intermediate verification be a statistical calculation on the repeatability of the standard after the most recent calibration and perform comparisons of each intermediate checks? Yes, of course, if you have control charts set up, and ideally you have a good system of intermediate checks, that can be used for a couple things. One of which is get your standard deviation, long-term standard deviation, which would account for your repeatability. The other thing it can be used for, of course, traceability. Mentioned that, yeah, it's not calibration is not a one-time thing. So typically, you send a standard in for calibration, you send it directly to NIST. That's not good for 10 years. You have to assure that the integrity of that calibration is being maintained. You need to originally put it on some sort of calibration interval. And you could, if you have a good system of intermediate checks where you can sense any sort of drift in the standard, that's good ammunition to perhaps after you get some history behind the instrumentation to increase the traceability. I didn't talk about that, but non-conforming work, for example, I mentioned when you look at a report, you want to assure that your device was in tolerance. That's one of the things you want to see off of the traceable organization's report. Was it in tolerance? Because if it wasn't, then you have to consider non-conforming work. So if you have a good system of intermediate checks, let's say if you had nothing in between there, you have a traceable calibration, nothing else done, say for a whole year, and then you send it off for recalibration, it was out of tolerance. When did it go out? If you had no way of knowing, you'd have to investigate. It could have gone out the day after you got it back, or it could have gone out the day before you sent it back. You would have that whole year that you may have to do a investigation. If you have a good system of intermediate checks, you put something in place right where it came back, then you could cut that down significantly. If you have a good system where you could detect perhaps it started shifting here, or if it's showing everything is stable through your system of intermediate checks, then maybe you just have to go back and look at the last time that you ran that intermediate check. But yes, the answer to your question is yes, that can be used, and I used to do it myself as far as a short of capturing data for repeatability. How do we start implementing decision rule? Okay, well, it's not what we discussed today. That's under uncertainty, which we will talk about next month. But I would say I'm not going to sit here and tell you how to start implementing a decision rule. You need to decide what your customers' requirements are. And if you want to take a look, we did a webinar on the decision rule on our recorded webinar. So that could be anything from simple acceptance, where you don't take it into account, on up to strict guard banding, 99% guard banding. So basically, the key thing with a decision rule, I know I'm going on to next month's topic here, is your customer has to agree to it. That's requirement as per 713. Your customer has to agree to your decision rule. And then that decision rule needs to be placed on the report. I'm not really sure. You're asking, start implementing decision rule on routine performances. So the decision rule is something that's documented on a calibration report. So this is something that your customer needs. And that's just if you're making a statement of compliance. If you're saying pass, fail, intolerance, out of tolerance, then you have to worry about the decision rule. So FYI, stay tuned next month. We'll talk about that, because a lot of it, there's some significant changes in PL-3, because the whole requirements with uncertainty and the decision rule has come up in the 2017. So we made quite a few revisions in PL-3, which we're going to talk about next month. But I have done a webinar before on that. So like I say, go to our website, www.pjlabs.com. If you want to look at what was presented before. No voice, please comment. Thank you. I got somebody claiming, thank you for my clarification. I'm not sure what that last question is. Let me see if I missed something here. I'm sorry, I'm not really catching the question there. I'm on. No voice, please comment. I'm not sure what the question is. All right, that very good questions there. Very good questions. Before we go though, I want to announce next month's webinar, which we had some questions in regard to this, and this is sort of a good follow-up one for PL-2. Is we're going to talk about PL-3 policy on uncertainty. Gentleman that was questioning uncertainty budgets and what needs to be included, probably have some examples of some budgets on that policy, because you still are required, as per PL-3 for calibration, to submit uncertainty budgets. So again, thank you for joining us today, and look forward to putting on another webinar next month. And it's been revised, so PL-3 has been revised. There's some significant changes in there. So look forward to you all tuning in and listening again next month, Friday, July 23rd. Thank you.